algebra, we're looking at functions, and we're specifically going to look at the idea of a function, what it is, compared to a relation. So you can identify functions and go from there. So let's get started. So two of the main ideas today is identifying a function, identifying a relation. Being able to apply the vertical line test to help you determine what you're actually dealing with. So, here we go. A function, what is it? Well, for function and relations, we're just looking at order pairs. We're looking at data sets. Anything that you can get points or order pairs out of is either a relation or a function. And a function is essentially just a well-behaved relation. So a relation is a set of order pairs. So right here you have a set of order pairs. We got our little, squiggly brackets. Oh, I messed up there. That's how I draw. A little off on this pad, but you get the idea. So you have your x, you have your y. You have your x, you have your y. You have your x, you have your y, and because you have an x and a y, it's a relation. Now it could be a function, because relations are everywhere. Functions have to follow a specific set of rules. So I like to think of it like, everybody gets into relationships, but most of them, a lot of them, don't work. And, maybe that hits a little close to home for some of you. But do they function? So in class we talked about vending machines and things where if you put an input, you get an output. So let's just see what it looks like in this situation. You have to map each and every input. So every single x value, every single domain value has to get mapped to one and only one output. So each x goes to only one y. That's how you know you have a function and not just a relation. So this relation from earlier, x, 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 right? They're all different. X goes to 2, 3 goes to 5, 5 goes to 3. Each x goes to only one y value. Therefore, this relation is a function. So every function that you come across is a relation, but every relation you come across is not a function. Make sure your relationship's working or cut that thing. Alright, so here are some more relations. These are non-functions. These don't follow the rules, so they will have either x's that go to multiple y's, or they might have an x that doesn't go to any y. Every input has to go to only one output. So if you look at this set of order pairs, you can see that -3 shows up twice, right? That's not necessarily bad. However, if you look at the different y values, x comma y, x come first, and then you get the reason why. 4 and 5, that one x goes to 2 different y's. That's not going to work. So that's a relation. And this is how you would write, say it. Here's a table. You have the same x, -1 twice. Again, you have to check the y though. And they both go to 0 and 3. So that has two outputs, not a function, just a relation. Here's a mapping. And you can see right away that 10 has arrows drawn to two different outputs. So that input has two outputs and they're different. Therefore, this is not a function. Vertical line test on a graph. If you draw a vertical line, that's kind of vertical, not really, and it touches the graph in more than one place, not a function. So all of these are relations. They don't work. Your x gave you more than one reason why. You don't need to be with them. But your x was talking to you and 11 at the same time. Relation, not a function. So get that down. Make sure you guys hit pause when you need to, whenever you're watching these videos. So functions. So these are well-behaved relations. They do what they're supposed to do. Every input goes to just one output. So we look at this set of order pairs, and we see each x goes to only one y. Now notice that we do have the same y value repeated, but that's okay. If I ask you guys how old you are, more than one of you are going to be 14 or 15. Or more than one of you are going to be of any age. Or if I ask you what shoe size you are, more than one of you are going to have the same shoe size. So there's multiple inputs. In these examples, you guys are the inputs. Can go to the same output. but they can't. The same input can't go to different outputs. And again, translate that down to some notes that make sense for you. You see here, each x goes to only one y. You see here, each x goes to only one y. And on the graph, if you wanted to check it, you draw a vertical line. You draw vertical lines every single place, and it only touches the graph, only touches one point of that graph. So therefore, all of those are functions. So make sure you know what the clear difference of identifying a relation versus a function just on site. Make sure you know that. You know, I gave the example in class. If you press A1 on a vending machine, you expect to get your Takis, or your purple Doritos, or your salt and vinegar chips. If you press A1 today and get your Takis, and tomorrow it gives you salt and vinegar chips, you press the same button, something's clearly not working. Or, if you press A1 and you get Takis and salt and vinegar chips, if that was your vending machine, you'd be salty. If you're the one that put the money in, you're probably happy. You had, 2 chips for the price of 1. But we want to make sure that with functions especially, you can make real-life analogies and metaphors and connections, and that's one of the reasons why I think this unit is really nice to work with, because it's not just theoretical, it's not just, solving an equation, it's not just procedural. This stuff shows up. Like if I ask you how many points did Giannis score on Sunday, they had 36, there's only one answer. If I ask you how many assists Chris Middleton had on Sunday, there's only one answer. If I ask you, did the Bucks win or lose on Sunday, there's only one answer. If I ask you how much money you get paid per hour at your job, there's only one answer. If I say if you work 10 hours at your job, how much will you get paid? There should only be one answer. So everything like that is an example of a function. And then if it doesn't work, if I say how much you can get paid if you work 8 hours, and you tell me, first day you tell me 60, and then you tell me 100, and then tell me 120, that don't make no sense. You get paid hourly, assuming you work at an hourly job. Alright. So we want functioning relationships. Relations matter. Like, you can say, okay, this is a relation, but don't call a function not a relation. So you want to make sure that each input, and again, I tend to group the verbiage here, x's, inputs, domains, together, so you can start seeing how those come together. To just one y, I'll put a range value. Each x goes to one y. When you're graphing, and I started talking about this, use the vertical line test. So when you graph, every x value should correspond to one y value, just like with this. So apply your order points, order pairs. You can draw as many as you need to. Now, in this, digital world, it might not be as easy to draw vertical lines, so I'll show you a couple ideas of what you can do to still use this as a check. But this, generally, you should know right away by looking at a graph if it's a function or not by practicing the vertical line test. So make sure that you embrace this idea. The vertical line test is a test to tell you if your graph is a graph of a function or a graph of a relation. So here's a bunch of examples. Now, let's say you didn't have, a paper in front of you, or you don't have a digital pen tool. Take a pencil and put it up against the screen and hold it and see, does this touch this graph more than once? And you can draw the lines everywhere. So, for example, a circle would very clearly see that it touches in 2 different points. Now, maybe you want to confirm, but just drawing one line that touches 2 points is valid. But maybe you drew a bunch of lines. And obviously you want them to be straight. I'm not that great with this thing, but clearly not a function. In this situation, you can draw lines everywhere and very clearly see that each line only touches the graph once. Now make sure when I say graph, I'm not talking about the grid, right? I'm not talking about the coordinate plane. This is not what we're talking about. We're talking about the actual graph, right? So on all of these, you draw your vertical lines, and you can see which ones touch once and which ones touch more than once. If it touches 2 times, 3 times, 5 times, it doesn't matter. Not a function. So I would personally make a note page in my notebook, or a section, or a note card, or whatever you do, and put a bunch of examples of functions that are graphs that are functions and pass, and show how you know it passes. And then I draw a bunch that aren't and show how you know they're not. Now, if you guys think back to Function Carnival, when we were doing the Cannon Man and the bumper cars and the roller coaster or Ferris wheel, there were times where people had multiple cannon people, multiple bumper cars showing up. That's because their line, you know, represented it would look like this maybe, or it looked like this, and it didn't pass. Oh, that's ugly. And it didn't pass the vertical line test. So if it doesn't pass the vertical line test, what you're saying is that at that specific input, at that specific value of time, at that specific day, you have more than one output. So if I'm looking at just this one, if I ask you the same question, oh, on Sunday when the Bucks played the Clippers, how many points did Giannis have? And if you say 36 and 38 and 52, you're tripping, dude. It can only be one. So that's how you test. Yep, my stuff. Don't steal my stuff. So, hopefully today you've learned how to identify what a function is. You've learned to identify what a relation is. You hopefully listened, and in your life you're going to look for real life functions. Get your relationships working compared to having relations. And I just realized my microphone's over there, so I might have to reshoot this video. Fun. Hit that subscribe button. I'll see you later.